Location data brings some of the most useful and rich and amazing experiences to users on mobile devices. Things like turn-by-turn directions. When was the last time you pulled out a paper map to figure out how to get from point A to point B? And if a road was closed, rerouting was pulling over to reconsult your paper map. Or, worse yet, having to actually talk to somebody to ask for directions. Next, recording the distance of a hike or a run or a bicycle ride. It's never been easier to map your route or monitor your progress, whether you're just a casual runner or training for something specific. And of course, discovering new restaurants and places of interest. It's become so easy to find the best places to eat, to drink, to sightsee, and of course, most importantly, the best places to take selfies. Now you can get reviews and recommendations from thousands of other users instead of just consulting the people that you know or buying a guide, which gets obsolete over time. However, location data is also some of our most personal information. As you heard in our keynote yesterday, privacy and security have been an important part of Android since the beginning, and it is a core part of Android Q. In Android Q, we extend transparency and control to users for their location data. Next, Praveen and Wang are going to dive into the details, but let me start with two driving principles that grounded how we thought about these changes. As a user, you want to be in control of your data, and you only want to share location with apps when it makes sense. We want to provide simple, discoverable, and easy-to-understand controls to users so they know what apps have access to their location and whether it's on or off. We'll talk in this session about how we're bringing more control to users about when apps can access their location. Second, we want users to have transparency over what apps have access to their location, especially when it might be unexpected. We'll also talk about how we're providing helpful reminders to users about when apps are accessing their location when in the background, so they can determine whether they want to continue that or not. Next, I'll hand it to Praveen to get us started.
Thanks. Hey, everyone. Very good morning to all of you, and thanks for joining us today. I'm Praveen Chandran. I'm a product manager in the Android Location Services team. As Jen said, we would like to provide simple, discoverable, easy-to-understand controls for users to be able to control access to location data. Users only want to share sensitive data like location with apps when it makes sense. So in Android Q, we have added the ability for users to control which apps can access their device location when they're not using the app. Now, before Android Q, location permission was really a binary choice in that a user could either allow or deny access to their device location. If a user provided location permission to an app, the app could get access to the user's device location when the user was using the app, but also when the user was not using the app. In Android Q, we have introduced a new location permission, allow only while using the app. If a user chooses this option, the app would be able to get access to the user's device location only when the user is using the app. For this new permission, how do we define when the app is in use? Well, there are two scenarios. For this permission, an app is considered to be in use when the user is looking at the app on their device screen, which is commonly known as a foreground activity, or when the app is running a foreground service. What's a good example of a foreground service? Let's just say you're using a navigation app, and you have requested turn-by-turn directions from the app. While the app is providing turn-by-turn directions, if you hit on the home button to get to the home screen, or you turn off the device screen altogether, you would notice that the navigation app would continue to provide directions even when you're on the home screen. Now, that's a good example of an app using a foreground service. Now, for the rest of this presentation, whenever we refer to an app being in use, or when we say an app is in the foreground, we are referring to foreground activity or foreground service. And every other type of activity is considered to be background activity. In a few minutes, I'll talk about some changes in queue related to getting location when running a foreground service. But before I talk about that, let me delve a little bit more into the details of this new permission. To get location permission, you need to declare access find location or access course location in the manifest. Typically, course location is at the city level, while find location is as best as we can do. Before Android Q, if you had specified access find location or access course location in the manifest, your app could get location in the foreground and in the background. In Android Q, if your app is targeting Q SDK, you should add a declaration for access background location in the manifest if your app needs to access the user's device location in the background, because your current declaration of access find location or access course location will only let your app access the device location when the app is in the foreground. However, if your app is targeting pre-Q SDK, your existing declaration of access find location or access course location would automatically be mapped to access background location, and there really is no way for apps to opt out of this automatic mapping. Now, one of the key benefits of targeting Q SDK is that if your app needs location permission only when the app is in the foreground, you can choose to request only this location permission from the user and get location when the app is in use. In other words, you can choose not to request location permission when the app is not in use, or rather, the app is in the background. As a best practice, we highly recommend developers to utilize this capability and always ask only for the permission needed for the app. Another key benefit of targeting Q SDK is that your app can now make incremental location permission requests. And incremental permission requests are incredibly helpful in presenting the location permission dialog whenever the user accesses the feature. Again, as a best practice, we recommend developers to show the permission dialog when the user accesses the relevant feature so that the user can understand why an app is asking for a certain permission or even for a certain level of permission. Let us say your app needs to access location in the foreground or in the background. Users are much more likely to grant the level of access needed for your app when users are requested to evaluate these permissions requests separately and at the time they're accessing the relevant feature. Let's take this example of My Train Commute app, which helps users manage their train commute. This app would provide the train schedule of a nearby train station based on the user's location when the user is looking at the app, and this app would send train commute notifications when the user is not actively looking at the app based on the user's background location. Now, for this app, when the user opens the app for the first time and the user wants to access train schedule, at that time, the app can show the dialog that you see on the screen, requesting only while-in-use permission. And the user is likely to understand why the app is asking for this permission, saying, yeah, I get it. In order to get the train schedule of a nearby station, this app needs to know my location now. And the user would be much more likely to provide this permission. Let's just say the user has provided this permission. Then the user looks around the app, reaches the train commute notifications feature, wants to opt in to train commute notifications. At that point in time, the app can show the permission dialog that you see here, requesting the user to provide the higher level of access, which is the ability to access device location all the time. If the dialog is presented at that time, the user would think, in order to send the notification, this app needs to access my location in the background. I get it, so I'll provide this level of access. As you can see from the dialog, in the incremental permission request, the user would have two options, either to allow the app to access the device location all the time, or to say, keep the current level of access. I don't want to provide the higher level of access. Now, to first request permission to access device location only in the foreground, you can specify access course location or access find location in the request permissions method. And if the user allows, your app would be able to access device location in the foreground. How do you request users for a higher level of access, or rather, the ability to access device location in the background? As a best practice, we recommend developers to first check if your app has access to device location in the foreground. And if it does, then you can specify access background location in the request permissions method to request the user for this higher level of access. On that note, how do you know if your app has access to device location in the foreground and or in the background? You can use the check self-permission method to see if your app has been granted access find location or access course location permission. And if it has been granted, your app can access the user's device location in the foreground. You can use the same method to check if the app has access background location permission granted. And if it has been granted, your app can now access the user's device location in the background. A key aspect to think about with this new permission is what is the impact of this new location permission based on the SDK version targeted by your app. Users will be able to set while-in-use permission for apps requesting location permission in Android Q. Users could go to settings and change the permission of your app from all the time to while-in-use. What does that mean for your app? If your app is targeting PSDK or lower, your app could get into a situation where your app is expecting location updates in the background, but the user would have changed the location permission for your app to while-in-use. At that point in time, your app cannot get location updates in the background, due to which some features that are dependent on background location may not work as intended. We highly suggest developers to handle the situation graciously and make sure the features that are dependent on background location would provide the right messaging to the user, letting them know that the app doesn't have this level of access, or make sure the features continue to work as intended even without background location. We also highly recommend developers to test and upgrade to QSDK as early as possible. Now, for this new permission, another key aspect to think about is what would happen to the location permission of apps when a user upgrades their device from Android Pie to Android Q. Well, the apps which had location permission in Android Pie would continue to retain the permissions even after the device upgrade. In other words, if an app had location permission in Android Pie, the app would be able to access the user's device location in the foreground and in the background even after the device upgrade. We chose to retain location permissions for apps on OS upgrade so that the user experiences do not break and the apps or the features in the apps continue to work as intended. A few slides back, we talked about when an app is considered to be in use. And at that point in time, I said we'll talk a little bit more about foreground services. In Q, we are introducing some changes to how apps can get device location when they are running a foreground service. But before we talk about the change, let's for a moment understand the need for accessing location when running a foreground service. When using an app, the user might use a feature that requires the app to access their device location even after the user gets to the home screen by hitting the home button, or if the user turns off the device screen. A good example, again, would be the navigation app that we spoke about a few minutes ago. Now, in the navigation app, if you remember, the user initiated an action in the app, requesting the app to provide turn-by-turn directions. And while the app was providing the turn-by-turn directions, the user hit the home button to get to the home screen. In such cases, the app should continue the action initiated by the user and continue to get location to provide turn-by-turn directions. In this example, the app would use a foreground service and needs to access location when running a foreground service. Typically, whenever an app needs to continue an action initiated by the user in the app would need to use a foreground service. Now, users expect this type of navigation to work even if the app only has while in use access. So to be in line with the user's expectations, the apps need to use foreground service and need to continue to get location when running a foreground service. Now, what's new in Q is that apps which need to get location when running a foreground service need to declare foreground service of type location in the manifest. We will be limiting permission usage based on this type of declaration. You can declare foreground service of type location using the foreground service type attribute in the service element of the manifest file. If you do not declare foreground service of type location, and if the user has provided only while in use permission to your app cannot get location when running a foreground service. If an app has all the time access, though, it can get location when running a foreground service even without this declaration in the manifest. If an app specifies foreground service of type location in the manifest, the app has to compile against the Q SDK version. Now, this change is for all apps, irrespective of the target SDK version. In other words, apps need to declare foreground service of type location in the manifest if the app wants to access location when running a foreground service, and the app has either only requested while in use permission or the user has only provided while in use permission to the app. On that note, there was a talk on adapting your apps for Android Q privacy requirements. I think it was at 8:30 today morning. The talk was given by Charmaine and Sweat. One of the aspects that was discussed in that presentation was the different types of foreground service. In this talk, I covered foreground service of type location. If you would like to know about the other types of foreground service, I highly recommend you should check out that talk on YouTube later. Now, at the beginning of the session, Jen talked about providing more visibility to the user on apps accessing the user's device location. As a way to bring more transparency and visibility to users in Android Q, we are introducing location reminder notifications. Location information is sensitive, and users share sensitive data like location when it makes sense. But occasionally, users could forget the level of location permission given to apps, especially the less frequently used apps. So we are going to gently nudge the user with a notification if the app accesses their device location when the user is not actively using the app. Here's an example of what that notification would look like in Android Q. In this case, the My Train Commute app has accessed the user's location when the app was not being used. So the user gets this notification, and the notification lets the user know that this app can access their device location all the time. At that point, when the user taps on the notification, the user will be directed to the location permission page of the app, where the user could make a decision on the right level of access for the app and can even choose to change the permission to while in use or deny. When does the user get this notification? The user will get a one-time per app notification when the user provides all the time location permission to an app and the app receives find location update in the background. To add a bit more context, if the user has provided all-the-time access, changes it to while in use or deny, and then eventually in the future, again reverts it back to all the time, the user might see the notification again. Till now, I have covered the features in Android Q intended to provide more visibility and control to users on apps accessing their device location. I now request Wei to come up on stage to talk about location permission considerations for Wi-Fi APIs.
Thanks, Praveen. Good morning, everyone. My name is Wang. I'm a software engineer in Android location team. Praveen talked about more control and better visibility of direct location access through location service APIs in Android Q. However, on Android, it's possible to get indirect location access from connectivity APIs, especially Wi-Fi APIs. As we all know, Wi-Fi connectivity is critical on mobile devices. As Wi-Fi devices become ubiquitous, people connect to Wi-Fi almost all the time. They connect to Wi-Fi access points to go to the internet, and connect to local Wi-Fi devices for peer-to-peer file transfer or managing IoT devices. Applications sometimes want to help users to connect to Wi-Fi devices. Before Q, Android provides APIs for Wi-Fi connectivity. Applications typically do a Wi-Fi scan first to get a list of nearby Wi-Fi networks and choose which Wi-Fi device to connect to. Knowing the nearby Wi-Fi devices makes it possible to derive the device location. So these APIs are protected by location permission. This causes a lot of confusion to users, as they just want to use the app for Wi-Fi connectivity and do not understand why the app requested location permission. So to solve this problem, on Android Q, we're introducing two new Wi-Fi APIs, Wi-Fi Network Suggestion and Wi-Fi Network Specify. Using these APIs, the application can tell the Wi-Fi system what Wi-Fi devices they want to connect to, and the Wi-Fi system will do the scan and decide whether to connect to those devices when they are in range. The key difference from the pre-Q API is, using the new APIs, the application will not get access to the nearby Wi-Fi device information. So the application does not need to request location permission. Furthermore, to better protect user privacy on Q, all the Wi-Fi APIs that have location information will be protected by fine location permission. So we highly recommend using the new APIs for Wi-Fi connectivity to avoid requesting location permission in your application. Let's take a deeper look at these APIs. The first API I want to talk about is Wi-Fi Network Suggestion. One of the main use cases for Wi-Fi connectivity is to connect the mobile device to the internet, so users can browse the web or communicate with others. Some applications may know certain networks that user can connect to when they go to airports, libraries, or coffee shops. On Q, such apps can use the Wi-Fi Network Suggestion APIs to recommend those networks to the Wi-Fi system. Let's look at an example. A local coffee shop wants to provide Wi-Fi internet to its customers when they enter the store. They want to recommend the Wi-Fi network to the device through the app called My Coffee Shop. So users can connect automatically when they enter the store, and let's see how it works. So first, the app needs to tell the Wi-Fi system what network to connect to. This is done by setting either the SSID or BSSID in the Wi-Fi network suggestion object. Also, the app needs to tell the Wi-Fi system how to connect to these networks. So if any credentials are needed for the Wi-Fi connection, the app also needs to provide that in the Wi-Fi network suggestion object. After that, you can simply call add network suggestions to add this suggestion to Wi-Fi manager. So we only use one network suggestion as an example here, but in practice, the coffee shop may own multiple different Wi-Fi networks, and the app can add a list of those suggestions. After these suggestions are successfully added, Wi-Fi system will be able to use these suggestions for connection. Once the Wi-Fi system detects the network suggested by the app are nearby, and these apps are best for Wi-Fi internet connectivity at that moment, it will show a notification to let users know that a network suggested by my coffee shop app is available for connection and request approval from the user. After the user approves the suggestion, next time, the Wi-Fi system will auto-connect to the networks suggested by the same app, if these networks are the best for connectivity at that moment. So the My Coffee Shop app only provides the suggestions. It does not get access to the nearby Wi-Fi device information, and it does not know that the suggested network has been connected. So it has no location access, and the app does not need to request location permission. Occasionally, application may want to know that the suggested network has been connected. For instance, the coffee shop may request user login before using their network, and My Coffee Shop app wants to log in users automatically after the connection instead of redirecting users to a captive portal. So Wi-Fi network suggestion provides the capability for this purpose. However, since the app knows the location of the Wi-Fi network, knowing the connection has been established makes it possible for the application to derive the device location. So this app will now request a location permission. Similar with the previous example, create a Wi-Fi network suggestion object with the SSID and the credential for the access point. The key here is set is app interaction required to indicate the application wants to be notified when the device has connected to the suggested network. Next, register a broadcast receiver to listen to Wi-Fi network suggestion post-connection broadcast. This broadcast is sent to the application when the network suggested by the app is connected. And as just said, knowing the connection makes it possible to derive the device location. So the broadcast is only sent to applications if it has been granted with access find location permission. So we recommend using this capability only when you have a very strong use case of doing so. All right, so that's the network suggestion API for suggesting access points for internet connectivity. Another large use case for Wi-Fi connectivity is connect to a local Wi-Fi device for peer-to-peer Wi-Fi connectivity. For instance, users might take photos with action cameras when they go skiing and would like to transfer those photos to the mobile phones later on. Or they may have a smart thermostat they want to set up using the app on their phone. For use cases like this, we introduced a new Wi-Fi network specifier API in Q. So here, we got an IoT device that needs some initial setup. It has no UI, so you might need to plug this into a computer for setup. Or more easily, using the Wi-Fi network specifier API, you can just power up the device, connect this to your mobile phone through Wi-Fi, and do the setup from an application running on the phone. The app will need to specify the SSID or BSSID pattern to match the IoT device. The phone can do the scans for the Wi-Fi devices matching these patterns. And once a matching Wi-Fi device is found, the system will pop up a dialog requesting users to connect and select which device to connect to. The system will remember user choice and auto-connect to the same device previously approved by the user. Similar with the Wi-Fi network suggestion API, the application doesn't have access to the nearby Wi-Fi information, so location permission is not needed. Now let's take a look at how to use this API. First, you'll need to create a Wi-Fi network specifier and specify how you find the peer devices. You can either set the SSID pattern or BSSID pattern as a regular expression to match the Wi-Fi devices you want to find. Next, create a network request using the network specifier. So the purpose of Wi-Fi network specifier is for peer-to-peer Wi-Fi connection instead of internet connectivity. So it's required to remove the internet connectivity from the network request. Once the network request is created, you can use the Euro Connectivity Manager APIs to request connecting to the network. As a recap, we just talked about two new Wi-Fi APIs for connectivity without location access: Wi-Fi network suggestion and Wi-Fi network specifier. These APIs provide the capability for applications to suggest access points or connect local Wi-Fi devices. Applications using these APIs don't have access to nearby Wi-Fi devices, so no location permission is needed. We recommend using these APIs for Wi-Fi connectivity purpose going forward. Especially, applications targeting Queue SDK won't be able to use the pre-queue APIs to auto-connect to a previously configured access point or config new server network. So these apps will need to migrate to the new APIs. And also, as I previously mentioned, all the Wi-Fi APIs that have location information will need access find location permission on queue. With that, Jen will come back to talk about best practices for using location. Thank you.
Thanks, Wei. Now that we've talked to how to update your apps for some of the new changes in Android Q, I'm going to summarize by talking through some of the best practices. First, don't use location data if you don't need it. As Wei just talked about, any API that provides location-related information will require the location permission. However, these new Wi-Fi suggestion and peer-to-peer APIs allow you to implement connectivity use cases without using location information. And so if your app supports these types of use cases, we encourage you to migrate to use these new APIs. This will also make the experience simpler for your users. Only ask for the permission that you need. One of the key benefits to the while in use permission is you can ask for that if that's the only permission that you need. Don't ask for all the time permission if all you need is while in use. This also makes the decision simpler and more straightforward for users. Also, as we mentioned, in the manifest, you can declare either coarse or fine location permission. As Praveen mentioned, coarse is approximately city level. And there's some use cases, such as weather, that work fine with just coarse location. So we encourage you to evaluate all the features within your app and decide if you really need fine location. Next, ask the user for location permission in context. We suggest surfacing the location permission prompt when the user interacts with or turns on a specific feature in your app that requires it. This also helps the user understand why your application is asking. We don't recommend surfacing the permission prompt on app startup unless it's absolutely obvious to the user why. 4, consider an incremental request. As Praveen had mentioned, you can ask for while in use permission first when the user is interacting with your app, and then later ask for all the time permission when the user is specifically turning on a feature that requires it. And finally, gracefully handle all levels of location permission. As always, users can change the location permission for any app at any time. We encourage you to gracefully handle when your app doesn't have background location or any location. We also recommend that non-location features within your app continue to work, even if you don't have location permission. Thank you for creating all these amazing location-based experiences for our users. We can do so much more today than we ever thought possible, and together we can create new, innovative experiences while keeping our users and their data safe. We hope the information that we've provided to you today is helpful in updating your apps to Android Q. A quick reminder that we have office hours later today at 11:30 and again tomorrow morning at 8:30 a.m. There's also a code lab on location that you can try out. Thank you so much.